Today we're looking at 1. Patterns, they're growing, observing patterns. Alright, let's take a look at the warm-up. Consider the block designs. Design 1, Design 2, Design 3. Design 4 and draw the design. So Design 4 is right here. So if you would go ahead and draw Design 4. Describe the observable patterns. As the design number increases by 1, the bottom row of blocks increases by 1. Each row above the bottom row of the design has one less block. The top row has one block. All right, go ahead and finish up the warm-up. All right, let's take a look at the next page. Covered in bees. You can find patterns everywhere. Sometimes you can describe them in terms of color, shape, size, or texture. Other times a pattern beauty isn't evident until you describe it mathematically. Let's consider the pattern found in nature. The family of tree of a male bee, female bees have two parents, a male and a female, whereas male bees have just one parent, a female. In this family tree, the parents appear below the original male bee. All right, so go ahead and take a look at that. Okay, the total number of bees in each generation follows a pattern. Describe the pattern for the number of bees in each generation. Let's actually ignore that. All right, determine the number of bees in the next generation. So let's look at generation 7, 8, and 9. Okay. So generation 1 has 1, generation 2 has 1, 3 has 2, 4 has 3, 5 has 5, 6 has 8. So 7 has. So basically, what you have to do is to get the next one is you add 1. So get 3 to get 2, that was 1 plus 1. To get 3, that's 2 plus 1. To get 5, that's 3 plus 2. To get 8, that's 5 plus 3. So to get 7, we take 8 plus 5, which is 13. So to get 8, that would be 13 plus 8, which is 21. And to get 9, that would be 21 plus 13, which is 34. Okay, let's take a look at the next piece. What is the mathematical rule that describes the pattern of the bees in each generation? So to find 3, f of 3 would be f of 3 minus 1 plus f of 3 minus 2, which equals f of 2 plus f of 1, which we know f of 1, looking from here, is 1, and f of 2 is 1, so that would be 1 plus 1, which equals 2. So then to find f of 4, we do f of 4 minus 1 plus f of 4 minus 2, which equals f of 3 plus f of 2, which would be 2 plus 1 equals 3. Okay, let's move on to the next page. Miriam owns a flooring company. Her latest job involves tile in a square room. Miriam's customer, Mr. Rivera, requests a tile pattern of alternating black, white, and gray tiles as shown. Each tile is 1 square foot. Analyze Miriam's design of a tile pattern for a square floor. Describe as many patterns as you can. The colors alternate with each new square, black, white, gray. The number of tiles along each edge increases by 2 in each design. 1, 3, 5, ... The number of new tiles added to each design is a multiple of 8, 8, 16, ... The total number of squares is equal to the number of tiles along the edge squared. 1, 9, 25, 49, ... Sketch the design for a square floor that is 9 feet by 9 feet. Okay, go ahead and sketch that. Let's take a look at the next page. All right, we're going to omit that page. So let's move on to the next page. All right, activity 1.2, reasoning with patterns. The class president, vice president, and treasurer of a high school count the ballots for the homecoming king election. The election result is generally kept a secret until the pep rally when the winner is announced in front of the entire senior class. Unfortunately, this year's ballot counters are not very good at keeping a secret. The very next day, after counting the ballots, each ballot counter tells 2 of their friends in the senior class the election result, but makes each friend vow not to spread the result. However, each of the ballot counter's friends cannot keep a secret. Either the following day, each friend of each ballot counter shares the election results with 2 of their friends in the senior class. The pattern continues for the entire week leading up to the pep rally. Create a visual model to represent this problem situation. So in day 1, you have the class president knows, the vice president knows, and the treasurer knows. But day 2, the class president tells 2 people, the vice president tells 2 people, and the treasurer tells 2 people. And each of those in day 3 tells 2 people, so you have 4, 4, and 4 each. So the number of seniors who learn about the secret doubles each day. All right, go ahead and finish that up. Okay, let's take a look at the next page. How many new seniors will know the winner of the homecoming king election on the 4th day? Well, in day 1, 3 people knew. In day 2, 6 people knew. In day 3, 12 people knew. So in day 4, 24 people will know. So the number of new seniors who knew the secret on the 4th day is 24. Okay. Now, the total number of students in the senior class is 250. If the ballot counter knew the election results on Monday, will every senior know the winner of the election when the result is announced at the pep rally 6 days later? Explain your reasoning. Okay. So Monday, day 1, 3 people knew. Day 2, 6 people knew. Day 3, which is Wednesday, 12 people knew. Thursday, 24 people knew. Friday, 48 people knew. Saturday, 96 people knew. And then Sunday, 192 people know. Give you a second to write that down. Okay. So let's add that up. So we have 3 plus 6 plus 12 plus 24 plus 48 plus 96 plus 192. And we can use Desmos to do that. So let's go to Desmos Scientific Calculator. So that's 3 plus 6 plus 12 plus 24 plus 48 plus 96 plus 192 is 381. So every senior will know the election results on day 7, which is 6 days later. On day 7, the number of seniors who know the election results is 381. All right, go ahead and finish that up. All right, 1.3, maximizing with patterns. Marina and Matthew were designing their backyard patio. There will be an entrance and exit off the front and back of the patio. The sequence shown represents different designs depending on the size of the patio. Analyze each design in the sequence. Describe as many patterns as you can. Okay, so here is design 4, design 5. Okay. Now, if you would, the student's going to work question 2 and 3 on this page. All right, so I'm going to give you some time to write this down and then work that. All right, so I assume but in the video, if you're moving on, you've completed 2 and 3. So let's go ahead and move on. All right, we're going to omit that page. We're also going to omit this page. And then the student's going to work 2A, 2B, and 2C. We're not going to worry about this. And the student's going to work 1 and 2. All right, go ahead and finish up your notes and your assignment and have a wonderful Wildcat day.